This is video 2, which starts with lesson 5. Just so you know, the mid-chapter check, we will not do this time. We're going to wait on the mid-chapter check. We are going to wait on the mid-chapter check. Now we are on lesson 5 of chapter 4. We're doing lesson 5. So scanning the lesson, the things that you're going to learn about. So we're going to compare two functions. Let's see, what else do we have? Yeah, we're just comparing a lot of functions. So in fact, that's what it even says right here. We're going to compare two functions. Okay. First one. Carlos and Stephanie belong to the Science Museum. Carlos's membership can be represented by this function, by the function c equals 9.99, where c represents the cost in dollars. The cost of Stephanie's membership is shown in the table. So here's Stephanie's membership. Make a table to represent Carlos's membership. And I don't think that, I think this was supposed to be an M right there. 9.99 M. They made a mistake. So add an M right there. So for 1 month, it's going to cost $9.99. For 2 months, it's going to be $9.99 times 2. So if you get out your calculator, $9.99 times 2, we would get $19.98. Then, so for the next one, 3. So we're going to do $9.99 times 3 and $29.97. And then 4, so $9.99 times 4 is $39.96. Just like that. So describe the rate of change for each function. So let's see. We're going to describe Stephanie's. The rate of change. So how much did we have? What do we have to times 1 by to get to 5? Or 2 to get to 10? Or 3 by to get to 15? Or 4 by to get to 20? Or 5 by to get to 25? So that to me looks like it's going to be $5 per month. So that is the rate of change, is $5 per month. Then for Carlos, it said right here, it's going to be $9.99 per month. Who pays more for a 2-month membership? 2 here, 2 there. What's more, $19.98 or 10? So Carlos pays more. And then we're just going to do $19.98 is greater than 10, and that's why. Who pays more for a 6-month membership? Carlos again. I think they actually gave us the wrong equation, but we're going to keep on going with it. Carlos pays always. I'll put always pays more. I think. Okay. All right. Let's do the next one. So functions can be represented by a table, graph, equation, or words. We've done this before. If you recognize back in other things, that we went over this. Oh, right here. See, words, equation, table, ordered pairs, graph. This one only talks about graph, table, equation, or words. So you can compare the functions represented in 2 different forms. So this is going to be tricky because it's a lot of reading. So I will do this as much as I can with you. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over a short distance. The graph at the right shows the speed of a zebra. Compare their speeds. So the zebra's is 53, and if we look here, feet per second. So this is the time in seconds. This is the zebra, and in 1 second it goes 59. So it went up 1 over 59. And then 2 goes 118. So we have to find both of them. So this is what I would do. I would do lion, 53 feet per second. And I can see that one went with 59, so the zebra is 59 feet per second. And I can see that because one went with 59. In 1 second, he went 59 feet. And that's it. So let's try this one. A certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sports utility vehicle is represented by the function below. So let's do car is 22 miles per gallon. So this one goes up 1 and over 19, and we can see that by the point here. So that means the sports utility vehicle, or the SUV, is 19 miles per gallon. So which one gets a better miles per gallon? So this car gets better miles per gallon. Okay, next part. So we just compared words to a graph. And the graph we did by using 1 and 19, like that first point was very helpful. For this next one, you need to write this down. Y equals mx plus b. We've learned this before, and then put that the m is the slope and the b is the y-intercept. That's where it starts. So write that down. Y equals mx plus b. Above m, write slope, and by b, write y-intercept. The y-intercept is where it starts, and the slope is how much it changes by. It's also the rate. So here's this first problem. The function m equals 140h, where m is the miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. Assume their relationships are between the two quantities is linear. So we're supposed to compare the functions y-intercept and rates of change. And I did this accidentally already, and I need to fix it. Okay, so first of all, we need to go back. To find out the y-intercepts, we need to go back to 0. So I've noticed, because I did 434 minus 217. If you do that in your calculator, you'd get 217. So I know that between here, that goes up 217. And then I checked it again. I took 434 and I added 217 and I got 651. So I can see that every time I'm adding 217. So if I had to go back down to 0 hours, I would get 0 miles. So for both of them, with this one, since there's no b on this one, and that went back to 0, their y, so the y-intercepts are both equal to 0. And then for the slopes, for Japan, the m, or the number that's supposed to be right there, is equal to 140. And then China, since each time we did 217, it's equal to 217. So since it says to compare, I can see that 217 is greater than 140. So China's rate is greater than Japan's. Good. And then they ask a specific question, this is what they put in this paragraph. I just said it smaller. Then they ask a specific question. If you ride each train for 5 hours, how far will you travel? So this is how I would do it. For Japan, I would do 140 times by 5. For China, I would do 217 times by 5. So 140 times by 5 is 700. And 217 times by 5 is 1085. Whew, that's a lot. So that's pretty far, miles. This is about halfway across our country in 5 hours. That's impressive by a train. Okay, then it's trying to see if you've got it. The number of new movies a store receives can be represented by the function this. So notice that this is the normal slope, and then that's the y-intercept. And then where M represents the number of movies, W represents the number of weeks. The number of games is at the store is shown at this. So we need to go back to 0, and now we're going to see how far apart these are. How far apart is it? How far is it to get from 3 to 6? Well, I'd add 3, right? And then 6 to 9, I also add 3. So if I need to go back to 0, I would subtract 3, and 3 subtract 3 is also 0. So this equation would be M is equal to 3, because we added 3 every time, W. And we're supposed to compare the functions y-intercepts and rate of change. So the y-intercept, so on, this is the number of movies a store receives can be represented this, and the number of games. So the movies is 2, the games is 0, and 2 is greater than 0. So they start with more movies than games, because the y-intercept is where they start. Pause the video if you need to write that down. For the slopes, then, so this slope is 3. So the movie slope, it's 7. And the games is 3. And since 7 is greater than 3, the movies rate is more than or greater than the games. Okay, so we're basically doing the same thing over and over again. If you need to get that down, pause it. I'll leave it at the top. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by this function. And X represents the minutes, Y is the cost. Benjamin's monthly is shown in this graph. So I can see that my y-intercept with Benjamin is at 60. So I'm going to write that equation. So it's going to be plus 60 because he started at 60. And then we want to know how far up and over he goes to get the rate. So he went up and over. So to me, this looks like from 60 to 72, he went up. So 72 minus 60 is 12. So he went up 12 and over, let's see now, from, up 12, and then now from the X to that. So over from 0 to 120 is just 120. And if I reduce 12 over 120, I get 0.1. So that's my slope for this line. So I would go 0.1x. So it would be y is equal to 0.1x plus 60. We're supposed to compare the y-intercepts and rate of change. So we have Angela and Benjamin. So Angela's y-intercept is 49. Benjamin's is 60. So since 60 is greater than 49, Benjamin starts with more. And now we need to do the rate of change. So this is, or the slopes, rates.